All right, let's take a look at number one. We have one where whenever they you have a right triangle and they labeled this angle x, whenever you have this idea of 90 minus x, they're just talking about the other angle. All right. So that is because the angles of a triangle add up to 180, and 90 of those degrees are here. So you have 90 left for the other two. So whatever this angle is, if you do 90 minus that angle, that's always the other angle. All right. So what they're really saying is the cosine of this angle is 3 over 11. So this is the adjacent side, and that is the hypotenuse. And then we want the cosine of this. So we're going to need this adjacent side from this angle. Well, we just need to do the Pythagorean theorem. So maybe I'll call that b. So we have 3 squared plus b squared equals 11 squared. We have 9 plus b squared is 121. And then we have b squared is 112. Now, we should simplify that. This 112 is not a perfect square, right? So we end up with the square root of 112. So it's clearly not these, right? Um, oh, and also, my bad. If we want to actually do the cosine of x, then it's that. It's the square root of 112, which is the adjacent side over the hypotenuse, right? So this is our answer, which again is clearly not one of these. So it's either B or A, and this can help us if you don't immediately know what this simplifies to. Clearly, we have a root 7 in there. So here, I'll do it down here. So we've got something and then root 7. Well, it ends up being 7 times 16 is 112. And the square root of 16, that's where the 4 comes from. So the answer is A. All right, on to number 2. Here's an example of one where they give you this idea where we have these right triangles that are similar to each other. And usually we only have to draw the one triangle. So I'm going to do this by only drawing the FGH triangle. Um, and I want to make sure, so I'm going to do it like this. Sometimes they tell you where the right angle is, but here we need to make sure that HF is the hypotenuse because it's the longest of the sides. So just letter them in a way where that's true. Okay, so then FG is 15 and GH is 20. Now, here's the key. A lot of times students will draw the second triangle and then it'll be similar and you end up like wasting a lot of time. The sine of x is the sine of f because similar triangles have all the same angles. And since they mentioned this f first, that corresponds to x. So f and x are the same angle. So the sine of x should be the sine of f. That simply is this angle, and the sine is the opposite over the hypotenuse. And 20 over 25 is going to reduce to 4 over 5. All right. So again, there's exceptions to any of these rules, but generally, if you have similar right triangles and it's a trig problem, don't draw the other triangle because it's going to end up kind of using a lot of time. And that's what they're going for on the SAT. They like to give you problems where there is kind of this like long way to do it, and then there's a little bit of a shorter way. And the more you can pick the shorter way and understand it, the better off you'll be because you'll save time. All right, on to number 3. Okay, this one is a pretty challenging problem, and I'm going to attempt to do it in what I mentioned on the last problem. So they give us A, B, which could be important. They give us DF, and they ask for the length of DE. Okay. So what I'm actually going to do is I'm only going to draw the DEF triangle. And they tell us angles B and E are right angles. So that means E is the right angle. So I'll put that first. So I got DEF. Now, what I'm going to do is I'm going to attempt to do this by only drawing the one triangle. This one is harder than the last problem, but it is still doable. And again, I want to draw just one triangle to save time. What is the length of DE? So I know that's X. DF is 12 root 2. And I'm going to ignore the AB right now because I don't want to draw that triangle. And then I want to notice this. A corresponds to D because they tell us, but also because it's the letter that's mentioned first, so they need to correspond to each other. So if they say the tan of A is root 7, that also means the tan of D is root 7. And this is the hard part here. The tan of D is root 7, okay? Well, that means when I divide the opposite by the adjacent, here's D, I have to get root 7. Well, then I'm going to make this x root 7 because x root 7 divided by x would give me root 7. That's the hardest part here to allow us to just use one triangle. And that means this part is unnecessary. And now we can just solve the problem because we want x and we're going to just do Pythagorean theorem. So I get x squared plus, let's do this. If you square this, you get 7x squared. All right, that's x squared and root 7 squared is 7. And then I just flip the order to write it the way that we're used to saying it. And then 12 root 2 squared. That's 12 squared, which is 144. Root 2 squared is 2. So that's 288. Now it's just pretty straightforward. 8x squared is 288. Divide each side by 8 and you get 36. So x is 6. And x is DE. All right, so I believe that's the quickest way to do it. You definitely could use the second triangle with AB and do it a little bit differently. But again, I really, really like to do these problems where I only need the one triangle and I make that adjustment. They're giving me information about A, but I'm going to flip it to D so that I can only deal with this triangle. On we go to number 4. So we've got a problem here where line segment AB is 12. Sine of A is 0.6. We'll get to that in a second. What's the radius of the circle? All right. What we have to realize here is, so I'm going to draw this in red. This is how I like to do these. So if they told me the sine of A was zero point 0.6, I want to think of that as a fraction. So that's 6 over 10, which is really 3 over 5. All right. Now, it does not mean that the sides have to be 6 and 10 or 3 and 5. It means they have to be in that ratio. So I like to write if it were just a blank triangle and they didn't tell me this was 12, then I probably would make them 3 and 5. But I'm not going to do that here because obviously 12 wouldn't really fit that. So my opposite is 3, but I'm going to put a circle around it because it doesn't have to be 3. It's likely a multiple of 3. And the hypotenuse has to be 5, so opposite over hypotenuse. Well, hopefully, we know immediately that this side would be 4. A 3, 4, 5 triangle, that is really important that we know that, and we don't have to waste any time with Pythagorean theorem, whether it's 3, 4, 5, 5, 12, 13. Those ones I really would just know. So you don't have to use the Pythagorean theorem in those instances. So now what happens is I'm going to go back to blue and I'm going to say, all right, well, it's a 3, 4, 5 triangle. And clearly I'm multiplying by 3 because that's where the 12 comes from, right? 4 times 3 is 12. So then if I multiply 5 by 3, I get 15. But 15 represents the hypotenuse, which is the diameter. They want to know the radius, so the radius is half of that, so we're going to do it as 15 over 2 or 7.5. Either answer would be acceptable. All right, let's keep it moving here with number 5. This one's pretty easy. You could plot these points in Desmos if you felt like it, but I just would do it real quick here. So points A are 4, 2. So again, just do it very loosely. B is 1, 2, and C is 1, 6. I really don't care about the scale as long as I track these numbers. And very quickly, what's the sine of A? Well, the sine is the opposite over the hypotenuse. Well, one thing I know is that this side is 3 because I'm going from 1 to 4. This side is 4 because I'm going from 2 to 6. And then very quickly, as in the last problem, I should immediately know that this is a 3, 4, 5 triangle. So therefore, the sine of A is the opposite over the hypotenuse. So my answer is 4 over 5. On we go. So here we are given the cosine of C. I'm gonna hold off before I write that. I'm gonna put in the other information first. We're given CB just because it's a ratio and I don't know that it's 4 and 5, so I want to be really careful about that. So CB is definitely 16. ED is definitely 6, and we want the length of AE. All right. Well, if the cosine is 4 over 5, so this is where I like to do this. The cosine is the adjacent over the hypotenuse. And also, I will just while I'm at it, that means that this is 3. So notice how often this 3, 4, 5 comes up. So now I know the big triangle is 3, 4, 5. So then I am going to go back here. So then I know I'm multiplying by 4. So that means AB is 12 and AC is 20. So now what I need to do is find length AE. Well, what I'm going to do is I'm going to find CE first. I'm just going to call that X. AE is not the length of a side of a triangle, so I'm going to save that for the end. X is the hypotenuse of this triangle. And then very simply, I could probably figure this out in my head, but let's say we want to set up a proportion. These triangles are going to be similar. So this 6 goes with 12, just like this hypotenuse, CE, goes with the full thing, which is 20, right? And you can pretty easily see that I'm multiplying by 2, so therefore x has to be 10. And if x is 10, then AE is 20 minus 10. AE is also 10. So the answer is 10. It's not actually this 10. In another problem where it wasn't exactly the same, we had to remember that I chose x here because it's part of a triangle, and then I have to subtract it from 20 to get the actual answer. Okay, now we kind of deviate from that a little bit. This question was submitted, someone from a practice test that they took. And this one's a little bit tricky. So what we want to do is they're telling us that it starts at number A and it goes up by K, and we want to find the sum of the first 13 numbers. This is a really good problem to choose your own values. And what I'm going to do is strategically choose A to be 1 and K to be 1, because that means I have a sequence that starts at 1 and goes up by 1. And when A is 1 and K is 1, then the sum of the first 13 numbers is X plus Y. So all I have to do is use this sequence, find the sum of the first 13 numbers, and I'm done, because that's X plus Y. Because again, I chose strategically A and K to be 1, so the answer just gives me what they were looking for. So all this is I'm adding up the 13 numbers where I start at 1 and I go up by 1. So that's just the sum of the first 13 numbers. You can do this a couple different ways. Um, you could just throw it in a calculator. If you want to get fancy with it, there is a little bit of a shortcut. If you add the first and the last number, you get 14. And if you add the second and the second to last, you get 14. You keep getting 14 over and over again. You end up with 6.5 pairs, because there's an odd number of numbers. So you get 6 pairs, and then that half a pair will be the 7 that's hanging out in the middle. So it ends up just being 14 times 6.5, which is 91. You definitely don't have to get that fancy with it. Adding 13 numbers in the calculator should not really take you very long. But If it's a bunch more numbers, then maybe. So again, the key is I chose these to be 1 so that the sum of the first 13 numbers, when A is 1 and K is 1, is X plus Y. So the value of X plus Y is 91. Okay, let's keep going. We got a couple more that we'll do tonight. So this is a good one. We switch over from trig to a little bit, special right triangles. So they're giving us the area of the equilateral triangle. So what we have to do is if you have an equilateral triangle or you see root 3, you will be dealing with 30, 60, 90s, on the SAT. So the area of a triangle is 1/2 base times height. And what I want to notice is if I drop an altitude from here, this right here is a 30, 60, 90. This has to be 60 because all the angles in an equilateral triangle are 60, because 60, 60, and 60 make 180. And if I have a 30, 60, 90, I'm just going to put the ratios that you're given on the reference sheet. So this is x root 3, and this is 2x. So now notice that the area of our triangle is 1/2 the base. Here we can get a little clever. 1/2 the base of the big triangle is this x, and the height is x root 3. And they tell us that that is 16 root 3. 16 root 3 is the area, and that's x squared root 3. Well, the root 3's cancel. X squared equals 16, so x is 4. Then we want the area of the square. Well, if the side length of the square is this, well, that's just 2 4s, which is 8. Or I'll just put the 8 over here. It's a square. They're all the same, right? So this was 4. That's 4. You get 8. And the area of a square with side length 8 is just 8 squared, which is 64. So it might be good to just notice that when you do the area of an equilateral triangle, that is x squared root 3, and x represents half the base. That's super important. Um, and that's how you can kind of come up with that, and it's useful, right? But if you forget that, the real key is anytime you see an equilateral triangle in the SAT, it's almost always going to be related to a 30, 60, 90. All right, let's just do a few more. So, a circle is inscribed in an equilateral triangle. So, let's take a look. We got an equilateral triangle, and then we're going to inscribe a circle the best I can. That's decent, I guess. It's good enough. So, the radius of the circle is 9 inches. So, here's the key. Whenever you draw your own radius of a circle, it's really important how you draw it. If I were to draw it like here, right, that I don't think would be too helpful, right? So I want to draw the radius in a way that's going to be helpful. And what I mean by that is I'm going to choose to draw the radius like that. And again, I have an equilateral triangle, so I automatically know that I'm going to be doing a 30, 60, 90 somewhere. And plus the answers all having root 3 in it. They're like clues that we're going to be using 30, 60, 90. And then I'm going to draw this. Okay. So now I know this angle was 60, so this is 30. Why it bisects it? I mean, we could get into that and dive deeper, but you got to just kind of trust me because we're trying to run through an SAT problem. But it does, in fact, bisect it. If you really want to look at it, you could just draw a bunch of these. And up here, notice that I've split the circle into 1, 2, 3, 4, 5, 6, and 360 divided by 6 makes that 60. So that's like another way to see that. So again, and then I want the perimeter of the triangle. Well, my ratios are x root 3. So this long side has to be 9 root 3. And notice that this part here, I end up having 6 of those that make up the whole triangle. And 6 times 9 root 3 is 54 root 3. If that's confusing to you, then this whole side would be 18 root 3. There would clearly be 3 of those, and 3 times 18 root 3 is again 54 root 3. So either way, we get C. All right, moving on. Let's do one more problem tonight. So we have an equilateral triangle has a perimeter of 42 root 3. So again, I see a root 3. I see an equilateral triangle. We are probably using 30, 60, 90s. And what I'm going to say is if the perimeter is 42 root 3, then if I divide by 3, then each side should be that. So each side should be 14 root 3. And the 30, 60, 90 comes from dropping the altitude. All right, because this is 60, so then this has to be 30, which means that this side is 7 root 3. And then if we look at the ratios for a 30, 60, 90, this side is x, this is x root 3, and this is 2x. Well, if what I want to do is I want to find the height, which is this x root 3, and x is 7 root 3. So what I'm going to do is x is 7 root 3, that's this part. And then I'm going to multiply that by root 3. So it looks a little strange for maybe, but 7 root 3 root 3. Well, root 3 times root 3 is 3, and 3 times 7 is 21. So the height of our triangle is going to be 21. All right, we will make that the last problem. Whoops. So again, thanks for coming. Check us out on TikTok and YouTube, where this video will live, both places. We also offer one-on-one tutoring, and we have 8-week SAT prep courses coming up. So call, text, or email for more information about that, and have a good one.